intrepid viewers. My name is Mr. Allshouse, and this is podcast number 2 of my AP Chemistry series. Today we're going to be looking at naming molecular compounds, such as sulfur trioxide that we see here, with 1 sulfur and 3 oxygens. This is ingredients in acid rain. With covalent compounds, and specifically in this podcast we're going to be looking at binary covalent compounds, are formed when we have 2 molecules that share electrons, as opposed to forming ions that are held together like magnets that we see in ionic compounds. Another name for covalent compounds is also molecular compounds. You will see these terms used pretty much interchangeably, at least at this level. So, in order to be a molecular or a covalent compound, we're going to have a nonmetal binding with a nonmetal. Carbon dioxide, sulfur trioxide. We even get hydrogen chloride if it's a gas, or hydrochloric acid if it's a liquid. We'll be talking more about hydrogens and how to name compounds with them in it in a later episode. For the purposes of this video, nonmetals are going to be anything to the right of that staircase. This includes carbon, nitrogen, sulfur, and even xenon and radon. I do not have helium, neon, and argon highlighted here because they tend not to form compounds under virtually any conditions. Krypton, xenon, and radon, even though they are noble gases, can form covalent compounds under certain conditions. Hydrogen could also be highlighted here, but seeing how I'm going to be covering that in a later video, I went ahead and left that off. So, the rules for naming a covalent compound. First, we name the first element, just like it was a cation if it was, or the metal in an ionic compound. We use its full name. We do not change the ending at all. The second nonmetal is named using the root of the element followed by IDE, or if it's a polyatomic, using its polyatomic name. This is the same thing as we saw in the anion in the ionic compound. Now, as we deviate from the ionic compounds, we now have to use Greek prefixes. Unlike the ionic compound, where we could work out how many of a ion we had based upon its charge, covalent compounds do not have charges and are not bonded in that way, so we need some way of denoting how many of each of those we have. The one caveat that is common is that mono is not used for the first element. Mono would be the Greek prefix for 1, but you will use it on the second element. A good way of remembering this is thinking of a common compound that we hear a lot about, carbon monoxide or monooxide. We do not use the mono on the first carbon, but we do use it on the second element, oxygen, which is oxide. So carbon monoxide. If we had 2 carbons, it would be dicarbon. It would be dicarbon trioxide or tetraoxide, most likely. So the Greek prefixes that you do need to know, and you will come in contact with these, at least up to number 8. Some of the examples I use will go all the way up to number 10. For 1, we use mono. For 2, we use di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 will be deca. Under certain circumstances, you will see even up to 20. My students, you do not need to memorize these, but I put these up here kind of as an idea that this continues. And for those of you who really like to geek out, you can get prefixes all the way up to 9,999. Now, you would not see these on these types of binary compounds. This would be something that is reserved almost exclusively for organic compounds, something like nanotubing even. Generally speaking, even in published texts, we don't use the official names when we get up to this level, but they actually write out the number, just the numeric value. But just to show you how this would work, 846 and 9,999 are written here. You would take the first digit at the ones place and name that first. digit at the tens place, you would name that second, and then the digit at the hundred place would be named third. If you have 1,000, you would name that fourth. Again, please do not memorize any of this. This is just for those who want to be assured that we're not going to run out of Greek prefixes. The ones you do need to remember are going to be these here, the 1 through 10. Those are going to be the ones that show up the most. So let's go through an example. Here I have SO3. For those of you paying attention, you might remember this name from earlier in this podcast. S is a nonmetal, O is a nonmetal. So we know that this is going to be a molecular compound covalently bonded. There are no ions formed, so we are not looking at the charges here like we did in the ionic compounds. S is named for using the full name of the element. S, if you remember from the periodic table, is going to be sulfur. Mono is not added to the first one. Even though there's one, we're not adding the prefix mono. O is named for the root followed by IDE, so oxygen becomes oxide. Tri is added to the oxygen because there are 3 of them. So we get sulfur trioxide. The sulfur, the S represents the sulfur. The oxygen is represented by oxide, and the 3 is represented by the tri. In the next example, we're going to name N2S5. N is a nonmetal, S is a nonmetal, so we can use this convention. N is named by using its full name. Di is added to the N because there is more than one of them. S is named with the IDE, so sulfur becomes sulfide. Penta is added to the sulfur because there are 5 of them. So we get N2S5 dinitrogen pentasulfide. Now go ahead, take a minute, pause the video, and name these examples. Hopefully everybody has named those, and let's go through the answers, see how you did. For the first one, we get carbon monoxide. The second one is carbon dioxide. The next one, already up on the screen, is dinitrogen monoxide, or monoxide. The next one is going to be dinitrogen trioxide. Next one is going to be dinitrogen pentaoxide. Next one is going to be carbon trioxide. Then we get phosphorus pentachloride. And lastly, we have carbon tetrachloride. Using what we have already learned, I am confident that you can go from a name to a formula. So here I put up a few names, pause the video, and come back to check when you're done. Let's go through these. The first one is going to be CCl4, carbon tetrachloride. Then I get CO3 for carbon trioxide. I get SF6 for sulfur hexafluoride. Dinitrogen heptaoxide is going to be N2O7. Sulfur trioxide is going to be SO3. Dinitrogen pentaoxide is going to be N2O5. A couple things that was not covered by the rules in this video is molecular compounds containing hydrogen, that would be a later video, organic compounds, which would be a much later topic, and oxides of phosphorus are often named as if phosphorus was a metal. So you would get phosphorus 4 oxide using the Roman numeral. I hope that this has helped, and I'll see you back here soon.